Hey everybody, tonight we're debating flat earth versus globe earth, and we are starting right now with Flat Earth Aussie's opening statement. Thanks for being with us, Iron Horse. The floor is all yours.
Thank you kindly, James, and thank you very much, Dr. John, for the opportunity to debate this subject again. I always appreciate the opportunity to debate with someone who is actually educated in the cult of heliocentrism beyond the typical, "Nuh-uh, you're wrong," and everybody knows it's a spinning space ball hurtling 10 times faster than an electromagnetic railgun projectile through a vacuum of space. It will be a refreshing change to see the scientific evidence from a qualified, indoctrinated physicist who can actually support the evidence beyond the usual argument that I'm just too dumb to understand and I should go back to school or at least read a book. My background is irrelevant to the foreground upon which I currently stand, and I stand firmly upon the stationary planar Earth fixed at the base of the universe. I challenge my opponent to prove otherwise. To begin with, I'd like to define what flat Earth really is before my opponent strawmans it, as most helios uncannily want to do. The stationary planar Earth, now nicknamed flat Earth, is simply the only physical realm fixed at the base of the universe. We speculate it may be infinite, but because our sun drifts from the Tropic of Cancer to Tropic of Capricorn, twice going around the equator on the equinoxes, that to the best of our current knowledge, the severely frozen Antarctic ice realm is the limits of the world as we currently know it. I don't need a doctorate in physics or engineering to know and understand the properties of liquid water. All liquids will flow without coercion towards the lowest place of resistance, whereupon they will fill the container with no part or particle sitting higher than any other, thus giving us our universal measurement and definition of the word level. I'm still in the process of finalising my book about perspective, which I've tentatively named Thatcher's Law of Perspective, based on a very simple principle and observation that even a 5-year-old child can do. I've revealed the simple method for free years ago, and I'm happy to share it for free once more for all to see. Simply touch your fingertips from both hands, if you have them, holding them together at stomach or chest height, something like this. You will see that your thumbs and forefingers make a kind of arrow or spearhead shape. Your thumbs seem to point down right at you, and a curving V pointing directly towards where you are seated. Your little fingers, your pinkies, kind of make an emerald, not really a triangle. And as you look at the shape every other finger makes, if you're honest, you'll see each makes a sharper arrow or spearhead as the steeple reaches the viewer, shaft of the spear. This is where the magic of Thatcher's Law of Perspective is revealed. I invite you now to raise your hands with fingertips still touching from your chest up to eye level. I can wait. By the time your fingers rise to eye level, the largest arrowhead between thumb tips and little fingers is now suddenly the flat and level base they were always on. And now you've just understood Thatcher's Law of Perspective. Go ahead, move them back down and up again, like so. Perspective is probably the single most misunderstood factor of our reality that has fooled many into believing in Earth's curvature, when in fact it is actually convergence, the visual optical illusion that draws every parallel line into a convergence point, always horizontal to the eye of every viewer, giving us the definition for the term horizon. Curvature is easily debunked simply by changing viewer height. It should be impossible to see over 6 feet of curvature drop 3 or more miles away by simply rising up a mere matter of a few feet. To see beyond physical curvature many miles away, one should have to move forwards and over it, not backwards and away, which is what moving up means on a sphere. However, on an infinitely flat surface with topography, going up extends the convergence point and allows us to see over obstructions that are nearer to us, thus appearing larger, than the further things that appear smaller due to distance diminution. It's easy to understand why ancient superstitious people might have mistaken the convergence point for curvature. Here in the modern age, with 21st century technology, there can be no excuse. Today, we can instantly send a drone up higher to see that the sun hasn't set behind curvature, and only an absolute simpleton would argue that sunset proves a globe. The digitally enhanced zoom camera proves boats do not disappear over curves, simply vanish bottom first due to angular resolution. And finally, the high-altitude balloon footage, able to be captured on modern, tiny digital video camera recorders, reveals a perfectly flat horizon at eye/camera level above a perfectly stationary, opaque, milky blue surface beneath, our Mother Earth. It is Easter Sunday here on Australia's eastern time zone between 11 a.m. and 12 p.m. And I put it to you that time zones are another flat Earth proof where the sun behaves like the hour hand of a 24-hour clock. This is a precise mechanical and logical fact that always brings the sun more or less directly overhead at midday, whether it drifts north inwards to the Tropic of Cancer or outwards south to the Tropic of Capricorn, twice crossing the equator on the equinoxes. It will always drift 15 degrees per hour. Thanks, Bob. Precisely 360 degrees every 24 hours. The spinning space ball, rotating 25,000 miles every 24 hours, however, has drifted 1,600,000 miles and therefore requires an additional 4 minutes of rotation each day to be facing the sun at midday. There's not a single physicist or engineer able to counter this argument, and the moment they attempt to use sidereal time, which is star time easily accounted for on the stationary planar Earth model, you will know they have lost. If I ask a helioist to reproduce a model of star trails from a sphere suspended in a warehouse decorated with fairy lights on every surface and a spotlight concentrated directly on 50% of the surface of the sphere, with cameras focused directly at both poles and reproduce perfectly circular star trails, even with the offer of a $10,000 reward, not one single heliotard has ever stepped forward to claim the bounty. Every person of a logically sound mind recognizes the impossibility of such an idea, yet many still cling to the absurdity of living on the outer surface of a molten-crusted, water-covered spinning spaceship, hurtling 10 times faster than an electromagnetic railgun projectile through a vacuum of space, while clouds drift, hot air balloons waft, insects, birds, and bugs fly, airplanes plane, helicopters chop, and winds blow any and every direction, as the helio-nonsensical belief calmly crumbles before us, and the globe belief is finally done and dusted.
Thank you very much for that opening. And folks, if it's your first time here at Modern Day Debate, want to say welcome. My name is Dr. James. I'm your host, and we are a fully neutral platform hosting debates on science, religion, and politics. And if you haven't heard, if you've been living in a cave on Mars with your fingers in your ears, and you didn't know, DebateCon 8, Modern Day Debates flagship event, is happening July 25th. This debate conference is going to knock your socks off. It will melt faces. Check out the link in the description box as well as the live chat. As you can see at the bottom right of your screen, it is stacked with huge debates. Check out DebateCon 8. We expect it to sell out, so grab your tickets fast. With that, thank you very much, Dr. John. We're thrilled to have you here as well. The floor is all yours for your opening.
All right. Well, thank you very much, James. I appreciate it. And Flat Earth Aussie, it's a pleasure to meet you as well. Although we might have some ideological disagreements, I think nothing's personal. And all's fair in love and war, right? So with that, I'd like to kind of briefly go through, I suppose, like when formulating this idea of like how we came about the globe in the first place. I think it's often glossed over the historical reasoning behind why we have a globe, and oftentimes flat earthers tend to strawman the argument. They like to pin the entire argument on like nebulous arguments about gravity, or that NASA doesn't exist and moon footage is fake, and these kind of strawman arguments for the globe. But I think it's worth taking some time into thinking, where did the human civilization originate with the globe in the first place? So with that, let me, hold on one second here. So let's start with a slight brief history of everything. And by everything, I mean essentially human civilization. How did these models of the world begin? So the first model that is traditionally accepted is that the ancient Egyptians had a flat Earth model back in 3000 BC. They assumed that the world was a flat circular disk with the Nile River running down the center, and ancient Egypt was in the center. Fast forward another 1,000 years, and we're up to the Babylonians. And the Babylonians also had a flat Earth model, but in their model they had the world divided into 4 quadrants, four corners of the world. Sometimes this language is echoed in the Bible. And the primary difference with their model and the ancient Egyptians is they put ancient Babylon in the center of the world. And after about 1,500 years, the Persian Empire invaded and took over the Babylon in 539, and then quickly thereafter took over Egypt. And then the Persian Empire dominated the region. And the Persians, around 550 BC, also had a flat Earth model. And they had, I mean, maybe it was a little bit more sophisticated than the Egyptians and the Babylonians, but pretty much they had this kind of flat container with this peak of Hara, which is really ascribed to some mountains in modern-day Iran. And this was what the Persians went with. And then another 150 years, and the Persian Empire fell in 334 BC to the ancient Greeks. And the reason I'm going through all of these empire and all this kind of ancient history is that notice the size of the civilization slowly increases throughout time. And essentially, the Greeks were in a very unique position now because their civilization covered a vast expanse of the globe, and they had an information flow going between these different regions of the empire. So why doesn't the flat Earth work? Why is it the ancient Greeks are the ones that developed a globe? Well, there's a couple observations that are often quoted. If you go just to the Mediterranean Sea, and you'll notice that as in Cairo, Egypt, the second brightest star of the sky is a star known as Canopus. Now, if you go directly across the Mediterranean, this star just disappears. And this might seem like a very subtle thing, but for the ancients, the sky was everything. They didn't have YouTube or Twitter. They had the stars. So this was kind of a mysterious. Where did it go? And not only just Canopus, the second brightest star of the sky, everything else just shifted downward. As if the light were being... So Canopus was as if it were being obstructed by the horizon. A physical obstruction. And not just in this random spot, it was everywhere above this imaginary horizontal line around the 37th degree latitude in today's modern maps. You cannot see this star. It just disappears. It's being physically obstructed by a curve. This is the experimental evidence for how the Greeks arrived and thinking that the Earth must be curved from north to south. So, is it like a cylinder? Well, not so fast, because what about east to west? Flat Earth mentioned that the Earth time zones were a reason for flat Earth, but it's actually the time zones were literally the reason why the Greeks saw a curvature. If you notice, if you travel from east to west, you get a 4 minute per degree delay in the sunrise and sunset times. And this really doesn't make sense other on a flat Earth. And this is what led the Greeks to think, well, it's actually curved from east to west. So is it 2 cylinders? Well, no. I mean, this would only make sense if it was just, if Greece was the center of the world. Even then, it's a little bit off. So no, the most reasonable is that the Earth curves in all directions like a ball, like a sphere. So this is the exact reason why the Greeks in 335 BC, predominantly Aristotle, who organized these thoughts, and his physics volume developed this spherical model of Earth. So this was thousands of years before the development of gravity or heliocentrism or any of these ideas that are often quoted for why the Earth can't be a sphere. But there's also some other observations. I kind of want to run through these fairly quickly. I'm not going to go into details. These are just more like possible talking points, but this is a pretty substantial amount of evidence for why the Earth should be a sphere. There's the phases of the moon. It's a pretty bit difficult to have phases on the moon when the sun and the Earth are just following each other. You would actually just get a single phase in that sort of flat Earth geometry. There's also the phases of Venus. Galileo observed this, but essentially Venus just disappears behind the sun for every 19 months or so. And also when it disappears because it travels behind the sun. We can't physically see it. And when it transits in front of the sun, we also can't see it. It gets saturated. So the phases of Venus are also very difficult to prove with a flat Earth model. Lunar eclipses. If the sun and the moon are circling above a flat Earth, how can the Earth's shadow get in front of the moon? I don't know. Good question. I don't think the flat earthers have an answer for that, other than just it's probably not Earth's shadow. All right, we have seasonal variability. That's the axial tilt of the Earth. In the summer, the southern hemisphere points towards the sun, and then the Earth goes around the sun. The north points toward the sun. Equinoxes are also very difficult to explain with a flat Earth model. This is a depiction of this ancient experiment from Eratosthenes in the early 3rd century. But there's some other problems with equinoxes. With the flat Earth, you have to have some strange requirements that light exhibit in order so that it covers exactly half of the disk. And we can run through that later if the interest is there, but you get some pretty logical absurdities for the behavior of light. And you have to basically make light behave in ways that it simply doesn't. There's for the motion of Earth, there's this Bradley aberration. This is a deflection of all starlight due to the velocity of Earth moving through space. There's the stellar parallax, which is also a wobble effect. This is more due to Earth's relative position around the sun at various times during the year. And this is precisely the method astronomers can use to deduce the distances of stars from our solar system. There's also the Coriolis effect for hurricanes. This literally cannot exist without Earth spinning like a ball. This is a Coriolis effect is a force due to a rotating reference frame. And notice that this hurricane is spinning in a clockwise manner. This is no coincidence. This is exactly what you should expect from a Coriolis effect, completely due to rotation. In the southern hemisphere, you only get clockwise rotating hurricanes. Also, very plausible on a globe Earth. You also get seismic data. You have earthquakes that transmit waves all throughout Earth's surface. Now, on a globe Earth, there's this understanding where you can detect seismic waves from earthquakes, and they radiate outward. And there's this P wave shadow zone. That is, people on the other side of the globe cannot detect the P waves emitted from earthquake's epicenter. And this is completely understood with a liquid core of Earth. It causes the waves to travel slower, which causes a deflection or a refraction of the waves through the liquid core of Earth. And this refraction effect causes a complete shadow zone. And this shadow zone is very well defined depending on where the epicenter of the earthquake is. Again, you can't really do this on a flat Earth. There's, of course, also GPS satellites, which are used to track planes. Satellites have to be clearly above planes, and they have to triangulate the position. Can't do that on a flat Earth. There's the star trails. These are star effects that northern hemisphere, stars all rotate counterclockwise. the southern hemisphere, they all rotate clockwise. Again, this doesn't really make sense for a flat Earth. There's the Foucault pendulum, which also precesses due to a pendulum just going back and forth, and it's being suspended on a very frictionless ball bearing while the building and the planet below it are spinning, and this precession is tracked exactly to the rotation rate of Earth. And it also, the precession rate changes based on the latitude in the exact way that you should expect on a spinning, rotating ball. I don't know how you could explain this on a flat Earth. And there's also the Cavendish experiment, where you get this local gravitational attraction between these massive objects. This has been repeated throughout all the world, and it's a very strong proof for a local attractive gravitational force. So there's a lot to mention. The final experiment, the 24-hour sun observed in Antarctica's southern sky, which was done. There's also, not to mention, the countless space organizations, not just NASA, but a plethora of millions of dollars being spent on space. And last but not least, we shouldn't just forget that Artemis 2, viewed by millions, invested NASA investments of billions, where astronauts in this very minute, as we speak, are on their way to the moon. So in light of this entire body of evidence and knowledge, and we still, in 2026, thousands of years after the first development of the globe model, we still have individuals that say Earth is flat. I don't understand it. I don't think there's strong arguments for it, but here we are. So with that, I'll yield my time.
Thank you very much for that opening as well. And folks, we are going to have a Q&A following the open dialogue. So if you happen to have any questions, you can submit them in the live chat by tagging me with @ModernDayDebate. Otherwise, you can use a super chat, which will push your question to the top of the list. And if you hadn't seen, at the bottom right of your screen, Modern Day Debate has a TikTok. If you like hanging out on TikTok, check our TikTok out. It's linked in the description box as well as pinned in the chat right now. With that, we'll kick it into open dialogue. Gentlemen, the floor is all yours.
Well, thank you very much, John. That was an interesting introduction, and I love your conclusion is that you just said you don't understand it. And that seems to be the main problem, is that once you do understand we're at the only physical base at the bottom of the universe, and all those lights, hence they're called light because they're not heavy, are revolving around above us, it starts to make sense. But you also have to stand, I think one was about the properties or the nature of light. And that is actually one of the biggest difficulties for people to understand, is that the light that we see, for example, coming from the sun, is coming through a direct line of sight through the atmosphere, and it's the atmosphere itself which glows, but it creates that visual hotspot, and that's the thing that we call the sun. So it doesn't matter where you are. You could be like 1,000 miles opposite, away from me, for example, and looking up, and you'll see the same hotspot, but in a completely different place, because it's in a visual line of sight to you through the atmosphere. And that's the biggest confusion, I think, as to why we don't understand how time zones work exactly as they do, even though it is still revolving around basically the equator every 24 hours, exactly 360 degrees. It still is going to appear to be in a slightly different place, and hence why everything is subjective to the viewer.
So how do you understand? So, okay, let's talk about the sun. You said it rotates in a flat Earth model around the equator. So that would be at the midpoint between the north and south. Is that correct?
Yeah, and it changes height throughout the year, and that's what creates the seasons. As it gets higher and higher, it creates a smaller circuit. hence the Tropic of Cancer. And as it gets lower and lower, it creates the larger circuit, Tropic of Capricorn. But it's still made through the same firmament, the same layer of atmosphere through which we see it, which makes it appear to move north and south.
So so what I want to ask is, if the sun is in fact, let's say, just circling around the equator, what is causing the light to just spontaneously stop right halfway on the flat disk? Light just travels in a straight line, right?
You mean like sunset, sunrise?
Yes. So because the distances are not the same, right?
Yeah, like you're dealing with
okay, so I almost want to like I don't know if I can draw out this. I can try if that's. Can I try?
You're dealing
try
with
this?
two different phenomena at the same time, right? Like one is the height of the projection coming through our atmosphere, and the other is we're dealing with our own personal perspective, looking at something. I don't know if that makes sense to you, but we see.
Well, I understand that there's a perspective, but then there's also. So look, if we have a flat disk, and then this is the center, and let's say the equator kind of somewhat midpoint, and then we have the sun here. Okay?
Sure.
Can you see this? And then
let's say from a God's eye point of view for this perspective.
Yes, bird's eye point of view.
Human's eye perspective when we're looking at it, and our horizon is generally only a few miles away. And so we're only seeing in a very, very, very tiny frame of reference the whole time. Like it would be less than the size of the dot you drew as the size of a sun. That would be, 1,000 miles.
I guess the question I have here is what would be the daytime on, if this is the sun, the yellow dot, would daytime be like all of this?
Yeah, but you're assuming the sun is in a physical location, whereas it's not. It's coming through the firmament, which is about, in my estimation, 60 to 70 miles high. And when it comes through that, we see it through multiple layers of atmosphere to a personal line of sight. So it doesn't really have a specific location. It's sort of like everywhere at once, but nowhere in particular.
But then how does it arbitrarily decide to like disappear and reappear in certain spots? Because
the viewer decides where that appears. The viewer is the one who decides where they see the sun. Well, they don't decide. It just is how it is. They see it in an actual location due to their perspective being very, very, very low to the surface, barely 6 feet high above the surface. And we only see it a few miles away where it seems to rise and set. We're not seeing that God's eye view of the world at any given moment in time.
Okay, because this is, this is kind of, it's a little bit, almost seems arbitrary if that's the way it's left. And I suppose my problem with this is, you can see these distances. The sunlight has to stop here, would just be like this, illogical. And then this is much longer distance, and you see these distances are just changing arbitrarily, and that's almost what would have to occur, right?
I get that. It seems very illogical because it's really not logical in many respects. Like if you were, say, a fish under a surface of a frozen lake and you see the sun, you are going to see that hot spot of the sun through the ice. And that's going to be, for all intents and purposes, to you, the fish, that's going to be the sun. And as you swim around, that hot spot is going to move with you. And as you move, you're going to see more and more areas which were previously in darkness. It's kind of a bit like that, only we're in a much bigger lake.
Okay. But you have to admit, like, the water is definitely a different medium than just the air.
Not really. It's sort of the same. I mean, it is a different, yes, but
But
it
light
is.
travels at a different.
It is
light travels differently through water than air, right?
Yeah. But it is
because I mean, it actually bends, right? It bends through the water, right?
That's debatable.
I'm not quite sure what's the debate point on that.
What do you mean it bends?
So if the light is coming in at a if the light is coming in, at
you mean refracts? Is that?
Yeah, refracts, right? It bends, right?
Yeah. If it changes through a medium, through some sort of lens, light will refract, but you're still only going to see what's available to be seen. It's not going to turn the atmosphere into a magical, projector of things that are already hidden behind stuff. It's not going to change anything. What you see is what you get. And if light be bent over, all you'd see was more light, but you wouldn't see things that are hidden behind.
So what would the light be refracting through on an atmosphere? Because even on a flat Earth, I would think the atmosphere is simply just air, is it not?
Yeah, it is, and that's why.
What is it bending through all these different angles?
It's the globers who argue for refraction. I don't. I just think it's rubbish. I think that what we see is what we get.
You don't think refractions? What do you mean? There's the globals who argue for refraction.
The globers always do. They say why we see too far. Oh, refraction. It somehow turns the atmosphere into some sort of magic periscope or something. But
you can see where but flipping that on its head, I'm giving you refraction, right? You're saying there is no refraction.
Refraction is your argument when you say
why. But you admit that it exists, right? It goes through. There is a refraction of like water, and there's a refraction of glass, and there's a refraction, and it's a temperature dependent quantity.
But that's more of a displacement thing. It's not going to show you something that's hidden behind something physical. So I'm not going to.
No, I mean you can. I mean, this is kind of like. And just our, I'm sorry. Let me show you. I mean, look, if you're a fish in the water down here, and the sunlight is coming in and it's shining, and that light ray is coming in here and it gets bent down to the fish. Where does the fish think the light is? It can still trace that ray. And it kind of thinks the sun is actually here when in fact it's over here, right?
Yeah,
you can trace the straight line back through the medium. So you don't have to, it's not just like a black box mystery as to where the light source is, right? And you can actually bend these lines back using the refractive index.
Yeah, and if that fish decided to use clever fissionometry and try to measure angles of shadows of reeds from one side of the lake to the other, he might conclude that hotspot image of the sun he sees on the surface is something like 93 million fish fins away, when in fact it's only 5 or 6 meters away the whole time. It's going to move with him. And that's how we've come to the problem with all the conclusions we've reached with saying the sun is 93 million miles away, when in fact it's only 12 to 14 miles high as we see it passing through our personal atmosphere in a direct line of sight from a much higher source point, which we don't really know exactly what that height is, but we sort of estimate our dome is about 60 to 70 miles high, where it passes through the inverted ocean of superfluid helium, where it makes the plasma apparition of the sun. And so when we see it through our personal line of sight, through the atmosphere, that's where our sun is. And it's only 12 to 14 miles high at all times. It's not 93 million miles away.
Okay, so are you saying then, and the reason I'm kind of hitting some of this refraction is you're saying that the light rays don't necessarily have to converge at a source.
It's a different thing when you're seeing the sun going further away. It's going to converge because everything that's beneath us in perspective always ramps up to eye level. It's an unavoidable fact of perspective. In a room, in a hallway, down a road, anywhere you go, the horizon is going to converge upwards to eye level. And so when something really high above us goes far enough away, it will disappear beyond that convergence point, bottom first, and it will appear as though it's going down, but it's obviously not if you use a bit of logic and common sense. It's a bit like if, say, you watch a cloud. If you walk towards a building with a cloud above it, as you get nearer and nearer to that building, that cloud is going to start getting disappeared behind that building. And you wouldn't for 1 second think, oh, the cloud has now gone below the building just because I got closer to it. It's all a matter of convergence and perspective. And the same is happening with the sun.
I get, but the building itself is like a physical obstruction, and I guess
So
the hang up here is there's no physical obstruction and just air, right? It's just air.
No, the ground is a physical obstruction.
But it's not. It's not getting between the sun and the observer.
It is. It does because it.
I don't understand how that could. I mean, there's no straight line geometry that would allow that to happen.
I know, it's not geometry. It's not straight line geometry. It's perspective.
Okay, but I mean, you're kind of conflating these ideas of geometry and perspective, and I don't. I mean, I don't really get it, because here's we got. Oh, I just deleted the thing here, but let me just go through it again. You have the light that's coming in, and then it dips down, and like I said, we have a fish, and its perspective is that the sun is here, right? That would be its perspective, but the reality is that the sun is here. And again, this is all just like light refraction. But what I'm saying here is we can track the perspective using physical laws, and there's no mysteries, right? We see that the perspective is this. This is the perspective.
I'm disagreeing with you, mate, because we're seeing it in a direct line of sight. So where that surface of the water is, the fish is going to be looking directly through that, and that's where he will see his hotspot of the sun. Whereas you're putting it as though it's bent, that's not really the case at all. It's a direct line of sight to each viewer. But if you put multiple fishes in multiple different places, they're all going to be seeing through that surface through a different spot, and that's where each of them will see their actual hotspot of the sun. You have to think of it through multiple perspectives, not just the single fish. There's billions and billions of people, and we're all looking through the atmosphere through a completely different place, seeing our hotspot of the sun in a completely different position, and that's how it is.
Okay, and I mean, okay, but it would vary drastically if the sun were local. If the sun were non-local, all of these rays are parallel, and they all will refract in the same manner.
Well, again, local is arbitrary.
Right?
Local is, if we're talking about something of great height, 12 to 14 miles high of our atmosphere is a massive height from a human perspective. The tallest building that humans have ever built is half a mile high. It's the Burj Khalifa. And we're talking about, what is it? It's half a mile. So we're talking 28 of them in height. It's a massive, massive height. And that's where the layer of the atmosphere is where we see our hotspot, coming from a source 60 to 70 miles high. So that's why it's such a tricky thing to understand. We're talking about phenomenon that most people have never even thought about before.
So I guess why was this cutoff? Is there any data for assessing this kind of height cutoff?
Today we have, multiple evidence of video of high altitude balloon footage. And pilots have been telling us for some time, the ones that can go above 65,000 feet, which is about the 12-mile height I'm talking about, is where they say they've reached the edge of space because the sky ceases fluorescing blue and goes into darkness. So this 12 to 14-mile height, seen through high-altitude balloon footage and pilots' testimony, is the edge of space, and that's the edge of our atmosphere. And light only exists when it passes through gross tangible matter. So it doesn't really exist beyond that. You see no starlight whatsoever above that height. But the sun, obviously, because it's
you see a starlight above the height.
No, you don't. You do not. That's
how can you say that? I don't understand, because
there's lots. I've studied this very carefully. This is my area of expertise, which I do on the side of,
what, like high altitude balloons?
High altitude balloons, yes. So you might call it exposure, you might call it whatever you like, but the fact is that stars do not exist above that certain height, and especially not at the 25-mile height limit, or 128,000 feet, slightly shy of 25 miles. That's the limits of what we can see, and all you can see is this massive glaring sun and this tiny speck of a moon and nothing else. That light needs gross physical matter to propagate, to reflect off, to shine through for our eyes to be able to perceive it, which is why, say, in city areas, for example, you don't see any starlight because the light itself is stealing the limelight, for want of a better term, of the stars. It's not exposure. It's literally they cannot propagate and create their own light through the atmosphere to the eyes of the viewer. The light is an atmospheric experience, existence.
I mean, in a cityscape, there's lots of heavy density fog or smog or particulates within the air that act as scattering centers for light.
Light pollution.
And yes. And the brightness intensity of stars, even the brightest ones in the sky, have a hard time penetrating through that. Not to mention our eyes ourselves are not that sensitive for that sort of light. So it's not...
you have a doctorate in physics, right? Could you
correct
explain to me, in your opinion, what light is, and I'll give you mine as a rebuttal.
Light is an electromagnetic field generated by accelerating charges and it can get emitted, and it propagates through a medium. Its speed is constant in the absence of any particulates or matter, like in the vacuum of space. But it can also propagate through mediums and materials. And
you're explaining what it's done. You're still explaining what it's
an electromagnetic field. So it can, an atom can, if the frequency of that field interacts with like some atomic nucleus, it can absorb that energy. It's a carrier of energy, and the atom can absorb that, and then that electron will get excited to some high energy state, and then it'll decay, and it'll re-emit the light, and it'll keep propagating in that way.
Okay.
And it's an electromagnetic. That's why they call it electromagnetic radiation, and its energy is related to its frequency of how fast those fields oscillate, and that's my idea of what
that explanation. And the way I would like to simplify it for the viewers to understand is it's a very similar effect to, say, you've got a packed stadium of people and you have a Mexican wave that flows through the stadium. Now, what actually happens is that the people are momentarily excited as they throw their hands in there, but nothing is actually traveling. So the wave itself might be traveling, but the light itself does not. It is just momentarily exciting the molecules of the atmosphere, which particularly react to that to create fluorescence, and that happens so fast that we don't notice the dark moments in between it. So light does not travel. It is an instantaneous effect.
So then in that context, if it were medium dependent,
yes, that's right.
Would the speed of the light, be faster or slower in a high density material? Just thinking about it.
It's not traveling. It's a reaction.
Okay, fine. It's a matter of what you were saying. It's the matter itself that's like oscillating around, and the one to the right. The right is like goes up, and then it kind of drags the thing to the left, and then it just sort of kind of goes like this.
Nothing really moves except the energy itself. The energy is not a physical medium. The energy comes from the sun, and it fluoresces the atmosphere instantaneously, and happens so fast we don't notice the dark moments in between. That's how our daylight works. Otherwise, we would not have night. If it wasn't because of our atmosphere, night would be constant starlight and daylight and sunlight and everything except for the shadow of the Earth in the heliocentric model. On the stationary planar Earth, what we have is a local sun going around creating the charge that illuminates the atmospheric gases, which gets dimmer and dimmer as it goes further away. And that's why we have the twilight, for example, because the neon gas is the first and last to fluoresce, and it fluoresces those beautiful orange and pink sort of colors that we see in twilight, which doesn't need direct sunlight. It is just the fading or coming into of the sunlight every day. That's why we have it. And the heat itself does not come from the sun, it comes from the Earth. And it comes from the production of the light and the intensity of its fluorescence reflecting off physical objects, which creates a heat, and it dissipates at cloud level, which is why we can sometimes see the fluorescent pinks and oranges reflected off the bottom of clouds, even though the sun is so-called set, because it's just gone away, but those atmospheric gases are still fluorescing, which is where the clouds condense. If heat came from the sun, clouds couldn't even exist. They would get boiled from above. Would be getting smashed by sunlight the whole time. You couldn't just stand in the shade of a tree and feel 10 degrees cooler all of a sudden because that light coming from 93 million miles away. No, the light comes from the atmosphere, fluoresced by the power of the sun, which is the electromagnetic source or electrostimulant source, exactly like a fluorescent light bulb. As soon as you apply electricity to it, it glows, and eventually you get some heat from it. Turn it off, it goes dark, and it's cold again. That's how it works on the flat Earth.
Okay, well, there are a few things. So I guess the idea that the light is medium specific, that's kind of what spawned all of that. And I mean, intuitively, if it in fact is medium dependent, its speed should actually increase, or it should go faster if you have a denser material, right? Because you have like more things that are moving.
It's exactly like sound. If you are underwater,
but see, that's the difference, though. No, that is how sound works. It's medium specific, correct?
Yeah,
but light, in fact, goes faster when there's nothing.
No,
the speed of light goes faster, and that's how the refraction works.
There is no light with nothing. It needs a medium in order to exist. Just the sound needs a medium to exist. There's no sound in a vacuum.
Okay. I'll tell you what. I will say, let's say it's medium specific, okay? But therefore, then, you would expect it to travel... You should expect it to travel slower in air than it does through water. But it's the exact inverse of that. But sound, on the other hand, does travel faster in liquid.
Exactly. So
sound travels faster in liquid, right? But light travels slower, and light speed reduces because it's not medium specific. So you see that there's there's conflicting observations here. Okay,
you've got it backward. You're disagreeing with yourself. You just said sound needs a more dense medium to propagate, but light needs less.
It's a different type of wave. It's a mechanical wave. without a these are distinct waves. That's the main thing here. That's what I'm saying. Light is a distinction. It's not medium specific. It's an electromagnetic wave. The thing that's oscillating is the electromagnetic field. It's a field. Okay. And sound is oscillating actual physical materials. That's why well, theoretically, if you have some kind of explosion or some kind of sound wave, it's not going to propagate through empty space because it needs actual materials to oscillate. So these are different. These are distinct waves. They're both waves, but one does not require a medium, and because of that,
requires the medium.
The medium slows the wave down, and that's how the light bends. That's how light. I mean, even with like the fish example, for instance, or I mean, you don't have to be a fish. You can be a scuba diver. You see light bending. It bends away from the angle at which it comes into the pool or whatever. It only does that because it slows down.
If or not refraction exists makes no difference. You still need the medium for light, for sound, for anything to exist. And we just happen to be the base of the universe, which is why we sort of, I try to describe everything as sound. Everything is on a sound frequency. Everything low is the base. That's why it's called base. And the deeper it gets, the downer it is. And then the lighter it is. Why do we call it lighter? Because it's not heavier. It's all on frequency and vibration. That's how Nikola Tesla told us to understand the secrets of the universe is frequency and vibration. And so light.
But there's distinct waves. He also realized that light is a distinct wave than a mechanical wave, which would be like a sound wave.
It's not mechanical.
Or even a seismic wave. Those are different. Those are different than light waves, right? They're distinct. There's like a physical mechanism that's propagating the light.
Is sound physical? Mechanical?
Yes, it's mechanical. It's considered a mechanical wave. Yeah, but it's. I mean, it's that like through air you get like these kind of these like high pressure, low pressure waves. One kind of hits on the air molecules to the right, and then it just propagates through the medium like that. That's how a speaker works, right? A speaker or a microphone, it oscillates a very fast little I don't know, like a magnet. They use an electromagnet and it oscillates, and that causes these waves that propagate
because waves cannot exist without the medium. So we need the medium, which is why we need the atmosphere for light to exist. Otherwise it doesn't. That's why night is dark, because space is dark. There's no medium. There's nothing there to light up. So it's dark.
Well, the reason it's dark in space is because there's a lack of medium. And there's no scattering centers. It's a very low dense. It's very low density. So the light just moves in straight line. It doesn't scatter. So the only things that we see that are emitting light are just these like very, very sharp pinpoints where just those little light rays from that little subsection of the light getting emitted is what we see. But because it's so low density, if it was high density in space, it would be just as bright there as on Earth, right?
Cool.
That's why it's dark in space.
You reckon that the lunar eclipse is caused by Earth's shadow? Can you explain the Salanelian eclipse?
I mean, okay, so why don't you enlighten the definition, because this is a very rare type of lunar eclipse. Is that correct?
No, it's every single lunar eclipse somewhere on Earth will see the Salanelian, which is where basically the sun and the moon are both still above the horizon, visible to both viewers, and you can still see a shadow coming onto the moon from the top down, which should be absolutely impossible. That's why it's also known as the impossible eclipse. Whereas in my opinion, the reason that a lunar eclipse happens on the stationary plane of Earth is because there are several different orbiting bodies around the sun, and one of them will occasionally come between the sun and the full moon, eclipsing it. And depending which one does it will determine the shade of the red that it turns. So it's never, ever Earth's shadow, because as we can see now.
So you were saying there was some other objects that are causing these things?
Yeah, the sun never goes beneath the Earth. The Earth is fixed at the base of the universe. The sun is set up there in the firmament, and the moon is hovering just beneath the superfluid ocean of helium. Superfluid ocean of helium, which is He3. So it acts as an anti-gravity device, basically, superconductivity device beneath that thing where it's reflecting the solar radiant energy down to it, but the moon and the sun never set below the Earth because nothing ever does.
So if there's some other objects within the sky, then... Yep. And you mentioned gravity, but I was under the impression that you didn't really... You're not happy with gravity. Is that fair?
Gravity's fine. It just means weight. That's not a problem. But we don't need it to make things stick to the undersurface or the sides of a space.
Well, so then what then is forcing everything to stick?
Nothing forces it. It just does what it does due to natural relative density. If it's more dense than air, it's going to fall through it. If it's less dense than air, it'll rise up. If it's less dense than water, it will float. If it's more dense than water, it will sink. It's the same thing. It's all just relative density. We don't need forces to make things do what they're going to do. They would just do it naturally.
But I mean, the whole idea of a force is that it's directing it directs motion, right? So the without force, if you have like zero force, then you're not getting. There's no reason to stay down.
The force is what changes its position. An object at rest will remain at rest unless another force acts upon it. And so for every force, there's an equal and opposite reaction. So if you apply a force to something like lifted it up, then obviously it's going to react to that force and drop back down again and come to rest because of the density of the medium that it's now in or upon that stops it moving any further. It's really simple.
Okay, but in that vein of thought, and I guess I'm also struggling a little bit with the idea of there being density without. But okay, regardless, what would not a more dense object then fall faster than a less dense object?
Only if there was a force applied to it, which would be called gravity. But because the only force is the resistance of air itself, because it's relative density, it's relative to the medium. The medium being air has the same resistance to any object regardless of its weight. And yet, if it's, say, like a feather, it will offer resistance to the feather, but it won't offer it to the brick. But if you put them both into a vacuum chamber where there is no air resistance whatsoever, they'll both drop at exactly the same rate. So the force is resistance, not attraction.
I guess I don't understand the resistance aspect of things that are falling towards Earth.
Air has some density. It's not much, but it's some. A vacuum is zero. Water is a lot. Ground is even more. So the more dense the medium, the more resistance it's going to give. So if you remove all resistance, like in a vacuum, then everything drops the same speed. You add air to it, then air will give some resistance to something like a feather. If you add water to it, well, then a rubber ball might not drop through it like a steel ball does, but they still will drop through air exactly the same rate.
I guess I think the whole idea of force is there's a net force is what causes an object. I mean, the reason why this moves up is because there's a net force acting up, right? And the reason why things fall down is that there's a net force. And I'm at the moment I'm countering that force. Right now there would be zero force acting on this, or zero net force.
No,
but there's equal and opposite forces, right? I'm pushing it up, and then gravity's
You
down, there's zero net force, right?
You are physically obstructing it. So your physicality is a force of obstruction. And if you remove that and you left it in air, well, obviously air doesn't have enough force to resist it, so it will drop. It's not really rocket science.
But okay, then what if I were to spin an object? I can spin like a pail of water, and I can hold it above my head. Why is it? Yeah. Why is it not fall just down?
So that's right? What we call centripetal force, and that's fine because it's the momentum of the motion. If you suddenly stopped it while it's right above your head, the water will drop straight out back onto you. But the centripetal force pushing it outwards due to momentum, which is the force you're putting upon it, will stop that from happening. This is one of the first things I came upon when I started questioning the nature of reality and the earth we live upon. It's like, it would make far more sense if we actually lived in the interior of a globe, and as it spun, that would explain gravity because everything's getting expelled outwards and water would still always find its level. It was only because of things like sunset and so forth, eventually I realized that we just live on a flat and stationary earth. But the centripetal force would make more sense if we lived inside of the hollow earth. If that gives you.
But it's not, I mean, the centripetal force, like if you live closer to the poles than at the equator, you're going to feel a different force, right?
Apparently, but they say
centripetal force.
They say it's so negligent. Well, that would be centrifugal because you're on the outside.
Correct.
Centripetal is pushing towards the inner surface.
Okay, so there would be a different centrifugal force on the equator than at the poles, correct?
Apparently,
if it's spinning. Okay, if it's spinning.
But I put that down to the density of the air itself. That makes things appear to weigh slightly different at the poles than they do at the equator, because you've got a different air pressure, and the greater the air pressure actually increases the apparent weight or something. But as soon as you calibrate the scales, everything's going to weigh the same anyway, everywhere anyway, so it doesn't really matter.
So there's a interesting experiment that was conducted in the days of the explorers to the New World, where these people exploring like South America and like Ecuador near the equator, they had their pendulum clocks, right? Which is how they used to tell time, right? And these things would oscillate, right? And it's essentially like as long as you kind of keep some mechanical motion going, they just oscillate back and forth, and the rate of oscillation you can track to the motion of the Earth, correct? Or you can track it to the day, okay? If you don't believe in Earth moving, you can track it to daytime, nighttime, 24 hours, right? That's how the pendulum clocks work. And the point being, near the equator, they were losing time. They were not, the period was faster at the equator than.
So how do you explain that? Because
towards the poles.
How do you explain that then? If the rotation of the Earth would be greatest at the equator?
Well, I know, right? That's pretty interesting. That rotation is affecting. Oh, let me talk. That rotation is affecting the Earth, the matter that makes up the Earth itself, and that's precisely why the shape of the Earth isn't a perfect sphere. It's actually bulging out. The oblate spheroid, right? Yeah. So if you actually calculate from that oblateness, that difference in period is because gravity is slightly weaker along the equator than at the poles. But that wouldn't happen if it were just density. If it were just density of air, because the density of air would be uniform.
Shouldn't more mass make more gravity?
I'm sorry?
Shouldn't more mass make more gravity, not less?
Well, it's proportional to mass and inversely proportional to the radius squared, right? So the radius being extended farther from the center of the Earth, that increase in radius it's a square, right? It's an inverse square law. So
does gravity get stronger if we dig a well or we go deeper down? Does gravity get stronger further towards the center?
That's a great question. And there's less, because you're getting closer radially. It depends on kind of how far deep you go. So it would actually it would start getting stronger to a point, but once you get through some of the denser parts of Earth, then the gravity would actually kind of start dipping down, because you're getting kind of pulled in opposite directions, and even though you're a shorter radius, but it does actually, if you get closer. But as I was saying about the seismic waves, like the Earth's interior isn't just a uniform mass.
Don't jump
right?
to another topic. Don't jump to another one. Let's not talk about seismic. I mean, I was going to talk about the atmosphere, where less and less dense molecules of gas get further and further away from the center of mass, somehow get pulled back even more, even though the center of gravity seems to be changing. Gets less as you go down, but also gets less further away. Like, I don't know.
The center of mass is still, I mean, an oblate spheroid is still kind of symmetric, right? So there's still, the center of mass is still at the center. And yes, gravity is much, much weaker for those air molecules, some X distance away.
Which have less and less mass further and further away. And yet somehow gravity seems to hold them down, as opposed to going into the void of the vacuum of the universe, which would...
Okay, right. Well, it does seem surprising, right?
Yeah.
You have to... But what is the... So using the model of gravity, there's an escape velocity, right? The escape velocity, like of an object to leave Earth, you have to get to a certain speed to just get ejected off, and it's quite fast. I think it's around like 25,000 miles per hour.
I think you're right. Yeah.
So if you look at the average velocity of air, the air molecules, which it's dependent on temperature and pressure and how many molecules we're even talking about, right? It's dependent on a lot of factors, but you can measure the pressure of air, and the pressure can be kind of related to how fast things are moving. And if the average pressure, the average velocity of air molecules, just like near the surface of the Earth, is like around 1,000 miles per hour. It's fast, but it's not 25,000 miles per hour fast.
So do you know what the orbital speed of the Earth is around the sun?
Not off the top of my head. I mean, in meters per second, probably several thousand meters per second.
Well,
maybe 2,000 meters per second. I don't know the figure off the top of my head.
We can talk in miles per hour, and it's 66,600 miles per hour, which is about Mach 86.8, something like that. So we're talking about 86.8 times the speed of sound is just our orbital speed. So every day as we're rotating on our axis 25,000 miles in 24 hours, we're traveling 1,600,000 miles all at the same time. And that's just in the day. And that's not even to mention the speed of the sun traveling 514,000 miles per hour in another direction, which are also moving through a vacuum of space. So the atmosphere cannot possibly exist on the helio-nonsensical model. It's as simple as that. The debate should be done now. We should be finished.
Okay, well, I guess we'll just call it Q&A now and call it quits. No, I mean, no. Well, look. So, but everything on Earth is feeling that force of gravity that's directed down, right? Directed towards the center, right? Everything, like everything on this side is feeling a force this way. Everything on this side is feeling a force this way, and that's.
everything is just on the base, and everything just comes to rest on the base because of relative density. There are no forces. We're not spinning through space. Please stop being insane. Thank you.
I mean, are you wanting a rebuttal here, or just is that?
I just think you should finally come to your senses and realize we're not spinning through space. And that's what the debate is.
You have to analyze the forces. I mean, you can't just say there's no forces because I don't want to talk about it, because I mean there are. I mean that's the whole crux of the argument of gravity, right? And if you ignore that, then you're not really considering gravity. And if you don't really consider gravity, then I don't blame you for not believing in gravity, because you're not applying it correctly, right?
It's a sweet argument that you've had since 1666, but now we live in the modern day and era, and we can do away with all the nonsense from these ancient superstitious people that believed in stuff that tried to put the Earth as a spinning ball in space. We are not.
It was 1687, but just for the record. But just.
So dates are semantic anyway.
It's a powerful argument. I mean, look, these are falsifiable claims. Okay, I mean, I think that's one of the powers in scientific arguing. Okay, is that they are in fact falsifiable. Mm-hmm. There was nobody that was putting a gun to somebody's head back 2,000 years ago that said, "Hey, we got to change the flat Earth to a sphere." This happened because these civilizations that evolved, they were wanting to be world superpowers, right? And to be a world superpower, your maps and your navigation and your sense of
so you're hiding.
You have to get stuff right, and the flat Earth wasn't cutting it.
From us, the plebs, who they've kept imprisoned here because they need workers to do their work for them. They know the Earth is flat.
But who's they? I mean, okay, now this seems to be cutting a little bit more towards the conspiratorial side of things.
The why? Why do they tell us it's a globe?
But who's they? I guess I want you to define, like, what do you mean by they?
Okay, so
because I'm telling you right now, I haven't been paid off by anybody to say what I'm saying, but perhaps I'm indoctrinated. But
you're a willing participant in what we call Stockholm Syndrome sufferance.
Well, I have yet to be convinced otherwise of a better model.
Inside the prison that they've made for you and for me.
There's no prison. I can walk outside. James and I were talking about being outside today because it was a beautiful day. There was no prison.
Can you go to the moon? Can you go to Neptune? You are.
I mean, but you can't do that on a flat Earth either.
Can you go beyond Antarctica? Antarctica is the ice wall that imprisons us. We think we live, because we're in a large enough game room, that we don't realize we're in prison in the first place, because we can go places, we can travel, we can do all this sort of stuff, but we are literally in some sort of physical prison. And so, yes, it does.
But, I mean, are you saying then that, I mean, you physically can't get past the ice wall either, if you say that there's some ice wall?
No, I can't. That's right.
So then what kind of prison, what's the difference?
What do you mean, what's the difference? We're all imprisoned in the same prison. It's just that some
so you're saying Earth is a prison?
Some of us think we're free.
Well, so you think Earth is a prison even for flat Earth? I mean, you're not, I mean, I guess I'm not really seeing...
I'm saying the truth sets you free. So when you understand the truth, at least in your mind, you're no longer in that prison, but you are in this prison. In most cases, it's like on this infinitely tiny little insignificant spinning blue speck of dust floating through space. When you understand we're on the physical ground of the universe, we're still imprisoned, but at least in our minds, we know where we are instead of believing in a fantasy. And I think that's why flat Earth is so important, because once you delete the fantasy of where you are, you start to come to reality of understanding all these other things that are bullshit, that we've been lied to about virtually everything.
Okay, so the counter side here, the counter remark I want to make here is that this idea that this globe, the fact that there's a globe and then there's these forces of gravity and these physical laws, the fact that, I mean, if you think that that's a prison in thought,
facts, bro.
I would beg to differ, because you can take these ideas and these tools and you can apply them to create things that are, I mean, they're interesting, they're fun. I mean, I don't agree with technology, like, can be a double-edged sword. I'm not saying that it's all good, but you can go out and you can make things from understanding these laws, and you can make
you don't need those
design things, and the stuff works. The stuff works. So it's a proof of principle, right?
You don't need the imaginary beliefs to make things. You can make things irrespective of the imaginary beliefs. You don't have to believe you live on a spinning space ball hurtling through a vacuum of space at unimaginable speeds. You don't need that. You know, once you're grounded in reality, you can do whatever.
Iron Horse, it's all cumulative, right? It's all cumulative. To say you don't need that is to say, well, I'm not going to apply forces and reasoning of physics and this idea here, but then to design this, I don't know, fiber optic cable system, I'm just going to apply these physical laws just for this subset of technology. The whole big idea of Newton was that these are universal. These apply not just to the globe, not just to spinning of spinning planets and planets orbiting sun. The same forces that cause these things to happen are what's causing, like, apples to fall out of trees, and that's kind of beautiful, I think. Like, it's like, and you use those same ideas to design these other things, right? And not to, well, no, I mean, I'm just, I don't understand why you can say it's like so, like, negative, when in fact I think it's quite opposite.
No, because when you make a positive claim about certain things, which is what the globe requires, it requires positive claims. It requires a rotation of 25,000 miles every 24 hours. It requires an orbital speed of 86.8 Mach through a vacuum of space. And yet you said in your opening statement something about satellites, and I'm telling you that a satellite is absolutely impossible on something that is doing those particular things. Like on the stationary planar Earth, we can send up a satelloon. We can send up technology fixed to a massive balloon, and it will go up and it will remain geostationary once it's above the atmospheric influences. That's not a problem. But when you start putting yourself hurtling through space 10 times faster than an electromagnetic railgun projectile and think that an unpowered piece of fucking equipment 20,000 miles away is going to stay in geostationary orbit, you're insane. It just cannot happen. Like, you should be a physicist. You should have enough brains to understand how something
you have to blast these things off with the rockets
orbiting around it, especially not something like an ISS once every 90 minutes. Now you can have it. Now, thank you.
Well, what I'm saying is, you have to, these things go up in rockets, right? And you can track the speed of the stuff. It's not just hot air balloons. I mean, I kind of live near a very, very actively used rocket base. They're blasting these things off, and they're always going supersonic speed. You don't just go supersonic speed and then just go up and then stop. You have to keep going.
Yes, but how are they keeping up with the Earth orbiting the sun 10 times faster than an electromagnetic railgun projectile? Those rockets don't even come close to going that speed.
They're along for the ride. Earth is taking them with it. They're already at. What is their speed when they're at the surface? What before launch? What is their speed? They're going along with Earth. They're at a constant. They're at the same speed. What's your speed in a 60-mile-an-hour car?
Okay, cool.
60 miles an hour, right?
Thought experiment. What about the skydiver who jumps from an aeroplane? Does he keep going 200 miles per hour with the aeroplane? No. In about a second.
Well, there's what.
Oh,
do you know why he stopped?
Yeah.
Do you know why he stops?
Rocket?
Because the air is stationary with respect to the plane, but they're both traveling on Earth.
So the rocket going 1,000 miles per hour to start with, going straight up.
It doesn't start that way, but yeah.
Yes, it does. I thought you said the Earth.
Yeah. Well, okay. With respect to the Earth, or with respect to the sun? With respect to the sun, yes, it's traveling just with Earth. Right on the surface, it's traveling at the same speed of Earth. It has to get to a relative speed.
Like the skydiver. Why doesn't it get air resistance like the skydiver? Why does the skydiver get air resistance but nothing else?
No, the rocket absolutely gets air resistance. That's why you have these booster rockets that get ejected. You've heard of like max Q? It has to get above this max resistance of the atmosphere, and that's why it's got to bring in all these extra booster rockets. And then once it gets past the dense part of air in the atmosphere, it ejects those boosters because it doesn't need them as much. It absolutely feels air resistance. Everything does.
Because the Earth is traveling away 86.8 times faster than the speed of sound. Gotcha. Once it's outside the atmosphere,
it's a relative effect, right? So the air. If you're in a car and you throw something out the window,
we're above the atmosphere, dude. Come on, stick with the project. We're talking about the rocket.
I'm sticking.
Above the atmosphere, it's used all its injectors. It's gotten out there. It's no longer in the atmosphere. No longer being projected with us. Lost all momentum. Why isn't it being left behind at the speed of freaking sound or light, I should say?
It's still moving with respect to the surface. It's moving fast, right?
Not that fast. It's only moving like.
It has to reach a certain orbital speed so that it orbits.
6,600 miles per hour through your vacuum of space and your stupid heliocentric belief. Come on, man. How can you have both? Either you've got one or the other, or both together, or you've got none, and all you've got is just the rocket going up above the stationary as we witness.
There's the atmosphere is there's no air resistance once you get past the atmosphere. That's why they go up there.
So how can it keep traveling with the speed of the Earth when the Earth is in its atmosphere?
The relative velocity of the object and Earth, it's going faster than that relative speed of the Earth. And it still has that same speed.
Relative speed.
Relative to the Earth.
Speed or there isn't speed. There's no such thing as relative speed. You got speed.
Yes, there is.
Or no speed.
That's why there. In a very, 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 very important concept is relative velocities of objects. And yes, there is a relative speed. And that's the thing with the car. Okay. That's why I went to a car, because it's a little bit easier to envision. But you just, you are in the car and you throw something up. In the car, you say your speed relative to that, like your seat back is just maybe like 1 meter a second up, but relative to the outside world, you're going 1 meter plus the speed of the car.
Yeah, but gravity says 9.8 meters per second squared. So if you're
for the acceleration, that's the acceleration.
Then you must throw a ball 10 meters high to experience 1 second of drop. Now, if you can think you can do that inside of a moving car, there's no such car that's 10 meters high, of course. So you have to use a convertible. If you think your ball is going to drop back into your lap in just 1 second, then you've just disproven that whole inertial reference frame. It doesn't work. You
You're
need
saying
at
that, and
least 10 meters to show a single second of drop.
if you were traveling in a double-decker bus and threw the thing, it would come right back on you.
Are you sure? Have you done that?
I'm 100% sure.
And that's only 3 meters. That's still not even a whole second. We need 10 meters to see a single second. And that's still got the back of the bus moving the air pressure forwards with it. On the outside surface of nothing with no back of the bus pressing it forth, there's no reason why things should fall backwards whatsoever. If we throw a ball 10 meters in the air, it should land like 100 meters over towards our west because of the rotation of the earth. Never happens.
You have to, it's whatever's moving with respect to the moving object. So like within the car, you're not getting bombarded by stagnant air, but when you're throwing something out the window, you get bombarded with like stagnant air. So the air relative to the car is a different.
I think you might have misspoken there. It's fresh air outside. And there's nothing to contain the air to push it forwards like it would do inside the interior of an enclosed, encapsulated.
I mentioned the velocities of the velocity required to escape the planet, and the air doesn't have it.
No, of course not, because the air's just sitting there. It's perfectly still unless there's wind. That's just how it works on the stationary plane of Earth.
What would be the countering force if you're moving at a constant velocity? What would cause wind? Why don't you feel wind when you're in a car?
You do. If you stick your hand out the window, you'll feel that air resistance
within the car. You're not in a vacuum.
You've got a windshield. You've got windows closed. That's why.
But there's still air. You acknowledge that there's still air in the vehicle, right?
Inside the.
Why aren't you getting a breeze? Why is the air not just whacking you in the face?
Exactly, because you have a wind shield. It's called a wind shield.
And there's air in the car. You're not in a vacuum chamber. Why aren't you getting wind in a car? Why is it stagnant?
So you're admitting that the Earth, even if it was a globe, would have to be within some sort of windshield, which would be an entire 360-degree dome, in order not to get smashed by that's 86.8 Mach wind facing it as it spins 1.3 Mach.
I am giving you the possibility that air can be stagnant and not feel like it's moving when you're in a car.
Yeah.
Because the air is moving with the car. The air within the car is moving with the car, right?
Yes.
How can you not see that?
Because that would be the opposite of being on the outside surface of a spinning space ball in a vacuum of space with no windshield. That's how I see that. How do you not see that?
Because the air on Earth is moving with Earth. It's stagnant. It's moving with Earth. Wind is a relative velocity of air with respect to the surface of Earth, right? So it blows with respect to the surface.
You don't even understand what a spinning space ball in outer space, in the vacuum in the void of the universe means. You are trying to use a completely non-analogous thing to argue for what you believe in.
Well, okay. It is a complete perfect analogy. You just refuse to accept it, but that's okay.
It's perfectly fine. Oh my gosh. Really? I thought you were meant to be an educated doctor in physics or something, and that's the best you can come up with. Oh, it's like being inside a car, inside a vacuum of space without windshields or a roof or doors or windows. It's the same. Seriously.
It's the same in the sense of relative velocity. Yes, absolutely. I don't know. I mean, I'm sorry if you don't believe in relative velocity or you think that that's just like some kind of made up liberal stuff, but it's not.
Let's go take some after something so I can understand what you're talking about.
This might be our time to go into the Q&A if you guys are ready. I feel like we've maybe hit an impasse, but we always enjoy it here, folks. If you haven't yet, check out our guest links in the description box. You can hear more from them And we do appreciate our guests. They're also linked in the description box at the podcast as well. So if you're listening there, you can find them there too. But in terms of the Q&A, we're going to jump into these and want to remind you folks, linked in the live chat is Modern Day Debates flagship conference, DEBATECON 8. As you can see at the bottom right of your screen, there's a big announcement in the next week, maybe even by Thursday. A huge announcement will come out regarding DEBATECON 8, in particular, a certain debate that has been booked. It's like right on the cusp of finally being confirmed, and it is going to melt faces. This first question coming in, well, we're going to wait for Iron Horse. In the meantime, that DEBATECON link for tickets is pinned at the top of the chat or bottom of the chat now. Let me know in chat. Folks, do you see pinned comments at the bottom or the top? Because on my browser, I see it on the bottom. And this is new for me. I'm going to look on mobile and see if it works the same way there. Because sometimes YouTube like does a little bit different. Okay, so it's pinned at the top if you're on mobile. It's pinned at the bottom if you are on browser.
Cool. I'm here, James.
We're ready to roll. Most of these questions are for you, Iron Horse, believe it or not. But this LJ says, why doesn't Earth, why doesn't Earth spin under a hovering helicopter?
Because helicopters have been pushed 1,000 miles per hour with the non-moving wind to make it appear like it's perfectly still.
Okay.
Trust me, bro.
This one from Matthew Akeem says, how do you guys feel about atheism, evolution, and globe losing every debate on this show? Okay. Some of these are just shit talkers. Okay. Flat Earth, my
I paid
ninjas.
money for them. They should be acknowledged for what they've, for at least announce their name for paying money.
But
They're
yes,
very upstanding people.
Matthew Akeem, thank you for your support. And we'll,
Yeah.
shoot me an email if you want to see if we can set up a debate. Chef Secret Sauce Nasty says, please, Dr. James, share yours and ask. Oh, yes. It's a real question. He wants to know what your guys' favorite pizza is. He asks often. It's still pepperoni for me. Iron Horse and Dr. John, do you have a favorite pizza?
We go for the vegetarian with chicken. I do eat chicken. Anything that isn't mammal, I'm able to eat. That's mine. Vegetarian with chicken.
Interesting. Dr. John.
Vegetarian sans chicken. I like the Hawaiian pizza.
That's cool. This one from LJ says, okay, just talking smack. We're looking for substantive questions.
Come on, LJ rocks. He supports your channel.
Okay, this is probably one of Iron Horse's sock accounts. He says 10-minute intro with zero verifiable proof we're on a ball.
Hey, he smashed it out.
LJ. Well, I would say go check out my channel. I have like details on all of this stuff. This was like an overview because there's a lot to talk about. If you wanted a 2-hour intro, I could have easily done that.
Check out our guest links indeed, folks. They're linked below in the description box. And this one from Knuckle Dragging Neanderthal says, I'm super curious what Iron Horse thinks about the Artemis 2 launch. There's video of the Earth and photos right now. There was a camera fixed to the rocket and recorded the whole thing. You're a fool. Whoa.
Oh, whoa. Yeah, I'm a fool. I'm a lunatic. I believe we can land on the moon. Of course we can.
But what about this Artemis launch? I want to hear what your thoughts are.
Yeah, look, we can send rockets up. That's not a problem, but they always come back down after they reach about the 25 to 30 mile mark. There's no atmosphere to propagate through, and so they lean back into their parabolic curve and fall back into the Bermuda Triangle, and that's how a rocket launches every time.
Okay. Folks, if you haven't yet, hit that like button. We do appreciate your support of the stream. This one coming in from Earthly Skeptic says, from a height, setting sun is below eye level. How?
because when there's no physical Earth in front of you because of your elevation, part of what is rising up to your eye level is still going to be the atmosphere. And because we can see through the atmosphere, that will allow us to see through that part, to see where the sun is before it gets obscured by the physical ground that normally obscures it when we're much lower.
Or it's just the ground.
Yeah.
This one from Emperor Fat Ass Dog says, if the Earth is flat, why is there no reports of people falling off the Earth, Iron Horse?
Because the physical base of the universe does not have an edge. We're at the base of the universe. It extends out infinitely, and to the best of our knowledge, what we're enclosed in is within this frozen dome that reaches to the extents beyond Antarctica. We cannot escape this realm, but it still goes forever.
Are you sure about this? Sorry,
Well,
I'm just. Oh, but wasn't there a question? I'm not trying to take sides. It's only because I think you asked Dr. John if he was sure about something. It's.
I'm not leaning in. I mean, I'm like, where's your proof? Proof is trust me, bro. I don't know.
Well, as I say, it is 100% speculation because we haven't been beyond the Antarctic ice wall in recorded human history unless it's been suppressed. So for the best of our knowledge, yeah, this is it. But I like to speculate it continues forever.
Got it.
And
I mean, that's not really a. It's like a belief, right? It's not really a.
No, it's a speculation. It's a hypothesis. It's a yet unproven thing. It's not a belief. It's speculation.
This one from Paul Brosfield says, wouldn't it make more sense for governments to prevent space travel instead of spending all this money and lying about everything?
Yeah, well, that's maybe why they're doing it, is because they're actually hiding all that money behind secret black ops projects instead.
Just to follow on that, I have worked for companies in the past that actually worked on satellite technologies, and those are the cameras that are being used in satellites to map out space, like JWST and other NASA projects. There was a lot of money, but I don't think it was wasted.
This one from Prod BT. Question for John. You said that NASA is on their way to the moon. Can you explain how propulsion works in the vacuum of space?
Well, I mean, it's just an action. It's just an action reaction, right? I mean, and furthermore, so the fuel itself is getting expelled, ejected. So for every action, there's an equal and opposite reaction. The fuel.
What's it reacting?
It's pushing the fuel's coming out, and then it's pushing the rocket forward. But I mean, by the way, once it gets into orbit, it no longer needs any propulsion whatsoever until to get to the moon. Then you do have to have like some extra boost to break free of that orbit. But it's just an action reaction. It's a combustion reaction, just like a bullet.
This one
in the atmosphere against the back of the bullet shell. Mm-hmm.
Well, it's not gunpowder though. It's liquid. It's liquid oxygen, hydrogen, right?
So where's the back of the bullet, and where's the stock of the gun that is reacting against to get shot forward? It's a vacuum of space.
The bullet is going forward, and that forward momentum is coming back.
Yeah, but it
on the gun, right? The gun. But the gun is a lot more massive than the bullet. That's why you don't feel like you just got shot by a bullet every time you shoot a gun.
That's right. But how does the rocket do that once it's in the vacuum of space is the question. And you can't answer that because it can't do it.
No, it's irrelevant. There's no, you have liquid oxygen and liquid hydrogen. That's enough to combust, right? You don't, there's no problem whatsoever.
This one from, do
It
appreciate
just shoots
Earthly,
forward.
Earthly Skeptic says, light bulbs with vacuum inside transmit light. How?
I
I
assume
didn't
that's for Iron
understand
Horse.
that. Vacuums
Iron,
of what?
yep. Iron Horse. Light
Yeah,
bulbs with a vacuum inside transmit
inside.
light. How?
They're not a vacuum inside. They have those particular gaseous elements. Quite often that mercury.
That's why they work if they break.
Is that
That's why
those
they work so well when they break.
when they're electrostimulated by the electricity. Same way the atmosphere lights up for daylight.
This one from, do appreciate it Earthly Skeptic says, how does relative density explain seesaw or pendulum?
Because it's on a physical rotor, like the seesaw, so it's in the rotor, and you've got two different weights, and as long as one applies a force and pushes itself up or whatever, the other will go down, and then to balance each other, it will seesaw. But that is a very good definition of relative density in the medium of air.
This one from, do appreciate it Earthly Skeptic says, do you enjoy seeing Polaris every night from Oz, Iron Horse?
We do not see Polaris from Australia because the equator is the 0 degree potential where it sinks into the convergence points because of the distance from it. You have to measure everything from on a protractor with 180 degrees, 90 degrees in the center. So when you're directly under Polaris, that's where it will be 90 degrees. And as you move further and further away, visually, it will appear to drop as you look through the protractor until you get to 0 degrees, the equator. So anything outside, south of the equator, will not see Polaris because it's beneath the convergence point.
You got it.
It's just the curve of the Earth is blocking it. Right?
But it only works on a flat Earth. If it was the curve, it would get exponentially further away the closer you got to the equator.
What do you mean exponentially further away? No, it wouldn't.
Try it. Try putting a fixed point and a ball and put a protractor on the ball and twist it as it rotates around. The further you got away looking outwards, the more that the degrees of change would rapidly increase to get exponential. If you use it on a flat surface and just move further away, it will just decrease linearly exactly as we see.
This one from Dupe.
Yeah.
Go ahead, Dr. John.
Well, a protractor only has 360 degrees, and if it's due north, it's directly above, and at the equator, that's 90 degrees. It's not exponentially away. And if you're on the south, that would be like 180 degrees, right? There's no like infinite exponential degree. I don't know really what you're talking about.
No, the equator is 0 degrees. You're looking at it.
The convention is, yes, the equator is 0 degrees, and everything, latitude lines, north and south, are with respect to that, right?
No.
So I don't know where this exponential thing is coming.
Latitude lines are with respect to Polaris inside of the equator, up to the equator. No more Polaris after that.
This one from Earthly Skeptic. Oh, we got that one. Andreas says, south of the equator, how come the sun sets diagonally down to the left and not curving down to the right?
Left and right are both arbitrary. Like you can look in the mirror and raise your right hand, and that person looking back at you is lifting his left hand. I mean, come on.
So it's a mirror? It's a mirror?
No, directions are arbitrary. If you turned around 180 degrees, your left is now your right, or your east is now your west.
That's what you specify with respect to a fixed point.
So if you turn around, well,
it's not arbitrary.
It's 100% arbitrary. It's all relative.
You measure with respect to a reference point, and with respect to that reference point, it is non-arbitrary, right? You have to map a coordinate system to your measurements, right? And everything's measured with respect to that coordinate system. It's not arbitrary.
With respect to your position where you are. But if I moved 100 meters forwards and used the same compass and said that's direct east, my direct east from up there would be a completely different direct east from what I'm seeing here. I'd be looking nearly northeast to see it. It's all arbitrary and relative to your position.
This one from, do appreciate it. Earthly Skeptic says, Iron Horse, have flat earthers launched a single satellite?
No, we've launched many satelloons though, and most of them burst at about 25 miles apart, and we retrieve their data and we see that the Earth is flat and stationary, and you cannot see continents through the atmospheric obscurity from 25 miles high because of the atmosphere. And yet these Artemis believers are thinking we can see it from 500,000 miles away or whatever they think, and we can see clear continents through the clouds. Thanks,
And
Ryan.
you see clouds too. You see clouds too.
But it look nothing like they look like in real photography that we can take from 25 miles high. Nothing at all like it. Real stuff.
Because
modern age, 21st century stuff.
I mean, you mean from space? Yeah. I mean, like in space, there's not an atmosphere, so yeah, it's going to look like a different from the other side of Earth and from like the ground. Yeah.
The Earth is always going to be covered in its same exact atmosphere. And the further away you got, the more obscure things would become because of the glow and the haze and the clouds and all the rest. And yet we see clear continents from so-called moon missions, and yet from 25 miles high, we can't see a single continent. It's all atmospheric haze.
This one from Retired. Oh, wait, this one from First Even Lord says, a question for both debaters. What is your favorite sun deity? Mine is the Japanese goddess Amaterasu. Not sure what they're getting at here. Do you have a favorite sun deity?
I guess, I mean, I had Zeus featured in my PowerPoint. I would say he's a pretty cool sun god. If I had to pick.
Oh, come on, man. Zeus is Jupiter. He's just the planet. The sun god
okay. Okay, you're right. I'll give you that. You're right. That's
when am I ever wrong?
When are you ever wrong? Well, that's debatable. But.
This is this one. Iron Horse, do you have a sun deity favorite?
Yeah, Helios, definitely Helios. Like he's that glowing orb of plasma in the helium superfluid ocean that we see. He's crowned in thorns, so he fits all the things. Yeah, definitely Helios. That's why I'm no longer a heliocentrist, because I understand he's just one lesser deities.
Well, I don't like heliocentrism, I'm just Helios.
This one from Retired says, Lisa Blair proves there is no flat earth, Iron Horse. Who's Lisa Blair?
Who is Lisa Blair? No idea.
I don't know who I'm not sure if I'm familiar with this proof.
I don't have an instant Google at my fingertips.
She's apparently an Australian sailor. An Australian solo sailor who holds multiple world sailing records.
Right. And what is she supposed to have done with that question? You said something about planet Earth.
This is interesting. This one from Retired as well says, how do isobars work on a flat Earth when under the dome the air pressure is the same from top to bottom?
Yeah, because the air isn't like that whatsoever. It's exactly like the ocean. How the ocean has a pressure greatest at the bottom of the ocean, and as you get higher and higher, the pressure gets less because there's less volume of water above you. So when you hit water level, then you got atmospheric pressure. So that's atmosphere base. And then as you get going higher and higher and higher, you get less and less atmosphere above you. So therefore less pressure. It's not like it's under pressure. It is just naturally pressurized because we're fixed at the base of the universe.
You got it.
I mean, I guess the only comment on that is like if we're just all under the constant downward non-force of Earth, then if everything's feeling that same non-force, then pressure really shouldn't exist.
Well, it does because of the volume. It's a finite.
Everything has the same. There's no radial dependence on it, right? If there's no force, there's no radial dependence. So what is the cause of a pressure? There's no pressure gradient, right?
Density. Everything has a density. Every elemental molecule has a density. And so if you've got gaseous molecules that have so little density, they can sort of waft above one another, and the heavier ones will sink towards the bottom where most of their oxygen and so forth is. But they do it on a density gradient, just as everything.
The density gradient is as a result of the gravitational field dependence on R.
The molecular makeup of every single thing. It's just how it is. You don't have to invent a force to make things work the way that they naturally work.
It's the same material, right? It's nitrogen, oxygen. There's no material difference in composition. It's just spaced out differently, right?
Respective to each other. That's why it's relative density.
This one from Blunder Statement says, just dropping in to support. Love you, Dr. Coons. Thanks for your kind words. And check out our guests. Links in the description, because, folks, the guests are the lifeblood of this channel. They are what make this fun. Like, I love Modern Day Debate, and people enjoy it, which we appreciate you guys being here watching live tonight and hitting like. But it's because of the debaters. I mean, that's why the show is fun. So check out their links in the description box right now. And I want to say, let me just double check to be sure we got all the questions. But it's been a true pleasure having you both here tonight, Iron Horse and Dr. John. This is a great debate. We had one last one come in. Riley, thanks for your question, said, Iron Horse, please explain how tides work on a flat, infinite plane if water is always level and flat.
Okay, so water is always seeking its level. It doesn't mean it's always at the same level. It's always going to be changing. On a globe, do I have enough time to answer this, James? Because I want to give a detailed answer. Right, yeah. So on a globe, you've got one mass of one moon, and they say that is pulling 2 tides per day, whereas you cannot pull water in the first place, especially not with invisible forces. At the very best, you can physically move the container to move water. So the only way you can move water is with a repellent force, which you can prove by getting a straw above a bowl or tray of water, whatever, and you put the straw just above the surface of that water and you pull as hard as you can, you will not budge that water one iota. But as soon as you start blowing on it slightly, you will easily repel the water. And so that is what the moon is doing above the stationary plane of Earth, is it reacts against the electrolyte-rich elements of the ocean water full of salt, and it is pushing down and is repelling the high tide away in front of it, and behind it a slightly lesser high tide. And directly beneath it will be the major low tide of the day. Fluid dynamics and topography take care of the rest. That is how we have tides on the stationary plane of Earth, and that cannot be explained by the spinning space ball with an impossible moon trying to keep up with the speeds that they say we go.
Thoughts on this?
Yeah, I mean, it's just gravity, right? And you have 2 massive bodies counteracting. And you can laugh all you want, but it makes a lot easier of an explanation than everything you just ranted about.
With one mass, how do you explain the second high tide?
There's an inertial effect, right? You've got
inertial effect. With all those continents in the way of 70%, 30% of their water-covered space ball, what's the inertial effect creating tides through those continents on the other side?
Well, water is it's all together, right? So it's just like one fluid, right? Mm-hmm. And you have when you're facing the moon, you have a greater gravitational attraction to the moon, and then turn around.
But the tides, I've observed for myself,
it bulges, right? It bulges. You have a bulge.
When the moon rises, and then the lowest tide will be when the moon is overhead.
You have a bulge. you have a bulge on one side, and
Uh-huh.
there's a finite volume. So if you bulge on one side, it's going to elongate, right?
No, that's not right. Don't look to me to confirm your claims. That's not right at all. That's ridiculous. There are
Okay.
entire regions where you pulled even stronger towards the side of the moon, which have created an even lower low tide on the opposite side, not a second high tide. It's just nonsense. Gravity is just the weirdest explanation for anything. It doesn't work anymore. We've analyzed it. It's broken.
You've analyzed speculating.
This one from Retired says, Lisa is the fastest person to sail solo, nonstop, and unassisted around Antarctica on her yacht, Climate Action.
Righty, I've heard about her. Yeah. I think she went through a bit of psychological turmoil through the trip as well, but it's still entirely possible, something we could do on this model as much as we probably couldn't do on the underside of a spinning space ball hurtling through a vacuum of space.
This
Just
one
me.
from Pseudonym says, for both, how is sea level measured on each model, i.e., when we say something is X amount of height above sea level, does that work?
I mean, yeah. I mean, it's going to be an average because the sea levels change based on tides or whatnot. But usually, you consider atmospheric pressure as being the pressure measured at sea level. So it's just the you usually count that as the gravitational equidistant position from center of Earth. That would be and that level around the entire globe is what we would consider sea level, and you measure heights relative to sea level. So if you study any types of physics, you know that the gravitational or any kind of potential energies measured with respect to it's only changes in potential energy that actually make differences. So you set some reference level, like sea level, and then anything above and below that is your change in potential energy. And water will go from high potential to low potential.
I would just say sea level is sea level, and we measure the differences above that level regardless. You never, ever actually calculate any curvature whatsoever. It would be the most insane thing to calculate how much curvature when you drive down the coast and say, oh, well, in 60 miles, I've now dropped a single Burj Khalifa of drop. It's just insane to think you would drop that.
You don't have to do that. I mean, you
the whole time, and water proves it.
No, you don't have to do that. You don't have to consider that. If you set your reference level at sea level as like your zero height, then it's just relative differences to that relative height. That's it.
Exactly. And water proves that we're not changing or going over a curve of a massive amount of drop in a small amount of distance. We're talking a massive amount of drop that has to everywhere.
A massive drop compared to what?
Distance must be half a mile of curvature drop for the Earth to be a sphere of 25,000 miles circumference. Any mathematician.
How far from at sea level? How far is sea level from the center of Earth at 37 degrees latitude, and then how far is the distance of sea level 50 degrees from latitude from the center? It's a circle, right? It's a sphere. That's how circles work. It's equal potential. That's how circles work.
Reality, mate. Everything
you're just
down. There's no center of the ball. There's no center of existence except the one you're living in, because that's where we all exist in, is within our own center. And if you are centered and grounded and understand reality, we're not on a spinning space ball. Water will not stick to all the sides, all the way around of it. You're insane.
With that, we will wrap up. Our guests are linked in the description box. Check them out. Want to say huge thank you to Iron Horse and Dr. John. It's been a true pleasure. Their channels are linked below. But again, thank you guys. It's been a great night. Thank you.
Cheers, James.
Thank you.
Thank you. Thank you, John.
Thank you, James. I really appreciate it.
My pleasure. I'll be
No,
back in a moment.
no hard
folks.
feelings, Iron Horse.
No, not at all.
Yeah. I'm that guy. Get out of here.
Amazing. Thanks so much for your support, folks. It's always a good time. Thanks for being modern day debaters. We appreciate you supporting this mission of this channel. In particular, let me load up my camera here. Got to tell you, we appreciate you hitting that like button. We appreciate you subscribing. We appreciate all the different ways that you support Modern Day Debate, which are many, and we just are grateful for that. So, let me do, let's see, window capture. We're going to get this out, get that out, and it should be a little one of me here. That's okay. Oh, there it is. Hold on. Thanks for your patience. All right. But I want to say thank you guys for your support. This is always fun. And here I am, right here. So thank you guys for your support. I always enjoy this. I'm going to go because this is actually my second stream today. So it has been fun, but it's also good for me to rest because I had a blast. And at the same time, I'm like, wow, that was about 6 hours of, nah, maybe not six. I would say more like 5 hours of streaming. But it's on top of a busy week this last week. I can tell you this, though. One of the cooler things is that DebateCon is looking amazing. You will see. You might be wondering, well, James, what do you mean? Give me more details. Keep an eye out. By this Thursday, we should have an announcement on a massive debate that is in the works for being booked. This is going to take us to the next level for Modern Day Debate's flagship event, DebateCon. And oh, I just saw that. Thanks for your last minute super chat. Let's see. Retired 2920. Sorry, I didn't get that. I didn't see that on time. So, but thank you for that. And want to say, folks, let's see. He said, though, I'm out of curiosity. I'm kind of curious what you said, retired. Said, so Iron Horse, stand up and show everybody how Lisa did it on a flat earth map. If you don't prove it, it can't be done. Well, perhaps next time. But I've got to tell you, check out the DebateCon link. That's in the description box. But also in the description box are links for our Facebook, which is pinned at the bottom or top of the chat, depending on if you're on mobile or if you're on desktop. You can find our Facebook page where we are uploading clips. Also, you're maybe like, yeah, I like Facebook. Okay, cool. Another one is Discord. I'm going to put that in the live chat right now. Check out the Modern Day Debate Discord. They commonly have after shows and all sorts of other cool stuff. It has got 16,000 members. So Shane and Hannah and others have done an amazing job of building that Discord to the behemoth size that it is. You have to check it out. I mean, if you love debates and all that good stuff, this is the Discord for you. If you are already in the Discord, please do support it. There are different ways that you can support it by giving it a boost or different memberships, things like that. The reason being is that basically the Discord is fully separate from Modern Day Debate in terms of, I said, Shane, hey, like however you want to do this. So it is like Shane is the ruler of it. And see, Iron Horse says, shame all the mods there have blocked me. We'll see what we can do, Iron Horse. Just to be fair, just in case, I don't know, but if you broke the rules, I can't help it. Maybe we can fix, get something to work again, but you have to consider maybe you broke the rules. But I want to say thank you guys for your support. Check out the Discord. Do support the Discord. There are cool things you can do like boosting it, checking out the subscriptions in there. But want to say thank you guys for all your support. Thank you guys for making modern day debate as fun as it is. Keep sifting out the reasonable from the unreasonable. We will see you at the next debate, which is actually, we have like a debate almost every day this coming week. It's going to be huge. So I'll give you a couple of quick ones I'll read out loud. On Tuesday, Brian Shapiro versus Deaf Noodles. On was Trump a better pick than Kamala? Then Israel versus Palestine. Who's in the right or who's in the wrong? That's on, was that Wednesday? Yeah, Wednesday. Thursday, our first anti-natalism debate. That will be a juicy one with Andrew Wilson, and that's the debate where we are planning on announcing the big news for the final schedule for DebateCon 8. Then Jay Dyer takes on Captain Tazariak on Friday, and then Saturday, another double header next Saturday. That is one debate on Islam and the other debate on, I can't remember. So you better tune in and then you'll be able to find out. So let's leave on that little cliffhanger. Thank you guys for your support. I want to say hello though in the live chat, as I do appreciate you guys hanging out here. So hello, Exotic Spida. Good to see you, as well as, let's see here, as well as Anton Shagur. Thank you for being with us. Arcade Outpost. Thanks for being with us. Yay, Area 7, Electron Element, Extra J 4868, PhD, Tony Original. Yay, Area 7, Iron Horse, Exotic Spida, Ben F7183, Dylan Motes 2719, Daryl Frost. Yay, Area 7, RF Gade, Forever Young 5, Dane Creek 3366. Thank you all for being subscribers. Thank you all for being supporters of Modern Day Debate. Seriously, it is a fun community here. You guys make this fun. We appreciate you guys supporting the mission. What is our mission? To provide a fully neutral platform where everybody has their chance to make their case on a level playing field. It is all debates here. So you might be like, whoa, is this like some sort of partisan flat earth or globe earth or Christian or atheist or Democrat or Republican channel? No, actually, like there are no videos other than debates. We always make sure if there's a view represented in any of our videos, the other opposing view will be represented with equal time, as well as our goal is to be fully neutral in that way. And so Modern Day Debate is not kind of going along any particular position. Is we want to give everybody a fair shot, and we do appreciate you supporting us because we believe YouTube deserves a better class of debate channel, and we're going to give it to them. Thank you guys for your support. We're excited about the future. The future is bright. Modern Day Debate is like a barreling locomotive going down the tracks, and it's just going to keep bursting through every hurdle it finds. Thank you guys for your support and making Modern Day Debate as strong as it is. Thank you to the speakers who are linked in the description box. Keep sifting out the reasonable from the unreasonable. Have a great rest of your night, and we'll see you next time.